It wasn't very long ago that I put up my last electronics tutorial, but I had a bit of free time tonight, so I thought I'd do a really quick one. This one is Diode Power Supply Polarity Protection, which is a practical application of the humble Rectifier Diode. I have already done a diode tutorial, but that was Introduction to Diodes, which just detailed the internal workings of a diode, the p-n junctions, majority carriers, minority carriers, depletion regions, things like that. If you haven't checked that one out, go check out my previous diode tutorial and then perhaps come back to this one, which is a practical application. So, what's this all about? Well, for diode power supply polarity protection, we're using a diode because if you recall from diodes, from the last tutorial, they only allow current to flow in one direction, and that is from the cathode through to the anode, if we're talking about electron current flow. So if we had a circuit, a very simple one, let's do this. So there's our diode. That's the cathode, that's the anode, so that's how the diode would be connected, because the grey band in this case shows you where the cathode is. And then we have some kind of load, in this case just a resistor. So if we had that circuit right there, we would have current flow negative through to positive, negative through to positive. So again, I deal with electron flow, and that's the way electrons go. If we were to turn the diode the other way around, so now we've got the power supply the same way around as before, but now the diode has the anode at the left, cathode at the right. There's our load. What we've done here is we've reverse biased the diode, which effectively makes it an open circuit. So it increases the depletion region inside, very high resistance, and we don't have any current flow. So we've got an open circuit now, right here. No current will flow in that circuit, so therefore no current flows through our load over here. So the reason this is handy is we can connect the diode in series with whatever our load is. So it could be a very expensive circuit, for instance. So let's just turn this page. So let's say we've got a circuit board here and it is expensive circuit, and it's got a positive connection and a negative connection. So that's how you connect your power supply to it. Now, because it is expensive, you don't want to accidentally connect the power supply up incorrectly. So what I mean by that is you don't want to accidentally connect the negative of your power supply to where the positive should go, and the positive through to where the negative could go, because that could cause current to go through it in the wrong direction, and just depending on what the actual circuit is, that could have some devastating effects and you could destroy it. That means it's bad. You don't want to do that. So, simple solution is to spend a couple of cents, get a rectifier diode. So in this case I've got a 1N5822, and we're going to put that in series with our circuit, just like we had it in series here, and that will protect the circuit against connecting the power supply up incorrectly. So let's have a look at this. Here's our expensive circuit again. There's our positive, there's our negative connection. I will connect the diode in. Doesn't matter which leg I put it on, it just matters which way around it is. If I wanted to put it on the negative end, I just have to flip that diode up the other way around. So now this forms my positive input, and this still just remains my negative. So just like we had previously, as long as we connect the power supply up correctly, that is positive to the positive, so there's the anode, cathode, negative to the negative, we're going to get current flow through the thing. So current will flow from negative through the circuit, do its thing in there, through the diode to positive. So the diode here is forward biased, which means it's turned on and it's allowing current to flow in the circuit. So that is all good. However, let's draw this exact same circuit up. Positive, negative. There's our diode, anode, cathode. And if someone was to come along and couldn't read positive and negatives properly, and they accidentally connected the negative over here, positive over here, that's on a pretty mean slant, isn't it? Instead of destroying the device, all we've done is we have connected the negative to the anode, the positive through the circuit to the cathode, so we have reverse biased the diode. And if you recall from the previous tutorial, if we reverse bias it, looking internally, we are opening up the depletion region even more. The depletion region is high resistance, so therefore it pretty much goes open circuit. So therefore no current will flow in the circuit and we're not going to destroy this. So in short, by putting the diode in series with our circuit, it will only ever let current flow in the correct direction that you want it to, or the way that you design your circuit. If for some reason you come along and accidentally connect the power supply or battery the wrong way around, this diode will be reverse biased, it will go open circuit, you won't get any current flow, and therefore you've protected your circuit. All you need to do is turn the battery the other way around and then it'll be all good again. Current will flow. Two things to think about. So the first thing is, I've just got Google here, so I'm going to search for this 1N5822, oops, you can't see that, 1N5822. I'm going to do a search for that on Google. First link that comes up is a PDF document, and it tells me here that this particular diode can handle 3 amps. So this is important because if you have a look here, all of the current that goes through your circuit will be flowing through that diode as well. So if your circuit was drawing 2 amps, you need to make sure that this diode can handle at least 2 amps. In this case, I recommend this particular diode because this one can handle 3 amps. So this one you've got plenty of room to move. The other thing to think about, and I'll just scroll down here, is VF. VF is the forward voltage drop of the diode, and it's normally specified in the data sheet at a specific current, but it doesn't generally sway from this too much. For our part number 1N5822, it's telling us that the diode will drop 525 millivolts. You need to take that into account with your circuit, because if your circuit here normally required 6 volts coming in between here and here, you need to take into account that this diode is going to grab 525 millivolts, or 0.525 volts. Therefore, you need to make sure that your power supply coming in is at least 6.525 volts. Normally, this isn't such a big deal because you might be using maybe, I don't know, let's say a 10 volt power supply. And in your circuit, you probably would have a regulator. And that regulator might regulate that down to maybe 5 volts. So it really doesn't make much difference that this will be grabbing 525 millivolts because your circuit would normally have a regulator in it anyway. Alright, that's it. I tried to make that one a pretty quick one. It still came up at around about 10 minutes. But a practical use for your simple cheap diode is to protect your circuit from accidentally connecting the power supply around the wrong way. Thank you very much for watching, and I will have another one soon-ish. Thank you.